Bismillahirrahmanirrahim. In this lecture, I am solving problem 3-59 from the book Thermodynamics and Engineering Approach by CENGEL, 5th edition. So the statement of the problem is a piston cylinder device and given data initially contain 50 liter of liquid. Initially volume is 50 liter. V1 is equal to 50 liter and liter is equal to dm cube. So 50 liter is equal to 50 dm cube, and if I convert dm cube and meter cube, so divide by 1000. So this will be equal to 50 divided by 1000 cubic meter, which is equal to 0.05 cubic meter. Initially volume is 0.05 at 40 degrees centigrade and 200 kilopascal. T1 is equal to 40 degrees centigrade and P1 is equal to 200 kilopascal. Heat is transferred to the water at constant pressure until the entire liquid is vaporized. Process is constant pressure process, and process pressure is equal to constant. It means that P1 is equal to P2 is equal to P is equal to 200 kilopascal. And at the end of the process, the entire liquid is vaporized. Vaporized means that finally the steam is saturated. So entire liquid, finally entire liquid is vaporized. It means that finally the vapor is dry saturated. It means that completely it converted into vapor. So this is dry vapor, no liquid involved in it. So required is, what is the mass of the water? First you have to find mass of the water. Secondly, find what is the final temperature and determine the total enthalpy change. What is the final temperature? T2. And at point C, find the total enthalpy change. And number D, show the process on a TV diagram with respect to saturation line. Draw the TV diagram and saturation line. So first we draw the TV diagram. Temperature is in degree centigrade and specific volume is in cubic meter per kilogram, and this is the saturation curve. So initially T1 is 40 and P1 is 200 kilopascal. So first we check that whether at 200 degrees kilopascal this temperature T1 is 40 is saturated temperature or superheated temperature or less than superheated, mean in the subcooled region or in the compressed liquid. This region is compressed liquid region. This region is mixed region, liquid plus vapor, and this region is superheated. So first, from saturated steam table, at pressure is given to us as 200 kilopascal. Saturation, first we find saturation temperature at this point. So this is temperature and this is 40 degrees centigrade temperature at at 200 kilopascal. This is pressure, and this is 200 kilopascal pressure. So at 200 kilopascal pressure, saturation temperature is 120.23 degrees centigrade. 120.23 degrees centigrade, and the temperature given to us is less than this value. Is temperature given to us T1 is 40 degrees centigrade is less than Ts. 120 saturation means, let's suppose this is constant temperature line. T1 is equal to 40 and temperature is in degrees centigrade. So from this point to this point, saturation temperature, this is saturated state, saturation temperature is 120.23 degrees centigrade, but the temperature given to us is 40, less than this value. It means that the temperature will be here in this region. So this is point 1 and subcooled region. So as T1 is less than Ts, it means so initially liquid is in subcooled region, and finally the steam is initial. This is initial point, then at constant, this is in this region, this is constant pressure line, and this is constant pressure line. So finally it is dry saturated, and this is saturated vapor line, this is saturated liquid line, and this is saturated vapor line. At this point the vapor are completely dry, so finally the steam is dry saturated. So this is initial point, this is point 1, and this is point 2. So this is the TV diagram for the steam. Initially for the working fluid, initially the working fluid or the liquid is in subcooled region or in compressed liquid region, and finally it is on the saturated vapor line, dry saturated vapor. So this is the TV diagram. Now first we find mass. This is the answer of point D. Now first we find mass. So initially the steam is in subcooled region, but I explain here a point. At this point and at this point, volume is almost constant, because here completely liquid and here the liquid is just boil. At this point the liquid is boil. So at the volume of liquid is constant at these two points. So it is difficult for me to find the volume at this point. So I will find volume at this point, VF. At this point volume is VF, at this point volume is VG, volume of liquid and volume of dry vapor. So Vf and at this point V1 is approximately same. There is no difference. So we neglect this difference, minute difference, and we neglect that minute difference. So V1 is equal to Vf. So first we find V1 per mass. First we find V1. So as we know that initially the liquid is, or the water is in compressed liquid region. So to find V1 specific volume, we find Vf at T1 is equal to 40 degrees centigrade, because V1 is almost equal to Vf. So from saturated steam table, at temperature T1 is equal to 40 degrees centigrade, V1 is equal to Vf is equal to, you can find the value from this table. This is temperature and this is temperature 40 degrees centigrade. So at this temperature Vf is equal to 0.001008. V1 is equal to Vf is equal to 0.001008. So we know that specific volume is equal to total volume divided by mass. Rearrange this equation and find mass. Mass is equal to total volume divided by specific volume, which is equal to total volume is given to us as 0.05 cubic meter available and given data, and specific volume is 0.001008 meter cube per kg. This unit is meter cube per kg. So this will be cancelled and kg is in double division. So mass will be equal to, so mass will be equal to 49.6 kg. This is the answer of part A. Part B is to find T2. So finally we know that finally the steam is dry saturated, as finally the liquid is completely vaporized. So completely vaporized. Completely vaporized mean that it is dry saturated. So temperature T2 is saturation temperature at pressure P2 is equal to 200 kilopascal. Saturation mean here, and this is the, from this point to this point temperature is constant, and here this is point 2. So temperature T2 is here. This is T2. This is T2, and from this point to this point temperature is constant, and which is Ts. So from saturated steam table at pressure is equal to 200 kilopascal. Saturation temperature T2 is equal to saturation temperature, which is equal to, this is pressure and this is 200 kilopascal. At this point saturation temperature is 120.23 degrees centigrade. This is the answer of point 2. And for part C, find del H, change in total enthalpy. So first we find H1. So H1 we suppose H1 to HF is, first we assume in the first part we assume that V1 is equal to Vf. V1 is equal to Vf because these two points are very close to each other. So V1 is equal to Vf. Now similarly these two points are very close to each other. So H1 is equal to Hf. So as H1 is in compressed liquid region, but it is very close to HF, so H1 is equal to HF. So from saturated steam table at pressure is equal to, at temperature T1 is equal to 40 degrees centigrade, HF is equal to, find the value from this table. This is temperature 40 degrees centigrade, and this value is H. So HF is equal to 167.54. This value is 167.54 kilojoule per kg, and H2 is unsaturated vapor line. So H2 is equal to Hg, which is equal to, H2 is equal to Hg at 200 kilopascal. This is pressure kilopascal, and this value is, sorry, Hg. 2 is equal to Hd, 2706.3, 2706.3 kilojoule per kg from the saturated steam table at pressure P2 is equal to 200 kilopascal. So now del H is equal to mass multiplied by H2 minus H1. So change in enthalpy is equal to mass. The value of M is 49.6 kilogram, 49.6 kg. H2 minus H1, H2 is equal to 2706.63 minus 167.54 kilojoule per kg. Kilogram will be cancelled by kilogram. So final answer of enthalpy is equal to 125,938.864 kilojoule. So this is the final answer of change in total enthalpy. And for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.